Pages 11 and 12, prime and composite numbers. So I mentioned prime numbers in the last video. A prime number is a number with exactly two factors, 1 and itself. So the only two numbers that divide in evenly, or a number that is only divisible by 1 and itself. And almost the opposite is a composite number. It's a number that has more than two factors. If you know anything about woodworking, when you make something with composite, or I'm sure there are other areas as well, it's just a bunch of things kind of thrown together. The number 1 is considered neither prime nor composite because its only factor is 1. It doesn't have two factors, it doesn't have more than two factors. 1 is just kind of its own thing. I want you to label these following numbers as prime, composite, or neither. And I'll go ahead and give you one of them. I'll tell you that number 8. When I look at that and use that little trick about 11s, 1 plus 3 is 4. 4 equals 4. This is divisible by 11, so it's not prime. In fact, this is 11 times 13. We're not asked for that though. We're just needing to say, hey, this is a composite number. Go ahead and look at the rest. Again, you can pause the video or do it after. And then we'll talk about prime factorizing a number. So to prime factorize a number, what that is that means the number is written as a product of only prime numbers. So we're just taking a bunch of primes and multiplying them together. We often use exponential notation for this. So let's get some examples. There are two ways to teach this. My favorite is using what I call upside down division. So I'm going to take 40 and I'm going to say, what's the smallest prime that goes into it? Well, the smallest prime that even exists is 2, and 2 goes into this, so let's take out a 2. Call this upside down division because I'm just going down. 2 goes into 40 20 times. Repeat the process. 2 again goes into 20. 2 goes into 10. We finally got down to a prime number at the bottom. That's when we stop. I have these 3 primes, these 3 2s, and then the 5. This is 2 cubed times 5. If you'd rather do a factor tree, that's fine. You take 40, split it up into, maybe you see it as 5 times 8. Okay, 5 is prime. 8, maybe that's 2 times 40. 4 is 2 times 2. These are all primes. I have, again, 2 to the 3rd power, or 2 cubed times 5. From now on, I'm doing the upside down division, but feel free to use the factor tree if that's what you prefer. I'm also going to take a look at number 6, 2475. And my upside down division, I see that 2 doesn't work. 5 jumps out at me, but I want to start with the smallest prime that works, so let's check 3. 2 plus 4 is 6, plus 7 is 13, plus 5 is 18. 3 goes into 18. So I'll take out a 3. 3 goes into 24 8 times. 3 goes into 75 25 times. Can we do the same trick? Can we take out another 3? 8 plus 2 is 10, plus 5 is 15. 3 goes into 15. So let's do that. 3 goes into 82. 3 goes into 8 twice. The remainder of 2. 3 goes into 22 7 times, with a remainder of 1. And 3 goes into 15 5 times. Got 3, 3, and 275. Let's try it again. 3's been working pretty well. 2 plus 7 is 9, plus 5 is 14. Doesn't work. That's okay. Now we'll take out our 5. 5 goes into 27 5 times, with 2 left over. Again, feel free to write that in, that sort of thing in if you'd like. 5 goes into 25 5 times. 2 didn't work and 3 didn't work before, they're certainly not going to work now. Once we've eliminated a number, we just keep going the same or up. I see that 5 works again, so I'll take that out. And I get 11. 11's prime. I can stop there as soon as I get a prime number down here. So I have 2 3s, so that's 3 squared, 2 5s, 5 squared, and an 11. I do want these in least to greatest order. So I don't want, say, 5 squared times 11 times 3 squared. I want them in increasing order. And the nice thing about this process is that it gives you them in the correct order. If you do a factor tree, like we did up here, we got the 5 first. Now, your friend might have factored it differently, maybe 4 times 10, and gotten the 2's kind of separated. Again, all of those work, but your final answer, we want an exponential notation, and we want it increasing, starting with the lowest number and going up. Let's take a look at the next page. Again, you'll be doing the other examples on your own, or we can do them together in class. So we're looking at Marie, and she is doing a tree diagram. So she's doing this kind of thing. It says she started with 9 and 8. Can she do that? Sure. 9 times 8 is 72. Okay. So now we're looking at A. A says, nope, she did it wrong. She should have done 2 and 36. Well, 2 and 36 works, but so does 9 and 8. This is okay. So this is a false statement, and we're going to justify why this is a false statement. Similarly, we're looking at her next set of factor pairs and another next set of factor pairs, and saying she didn't have to use a tree diagram. So which of those are true? Which of those are false? And that's pages 11 and 12. Quick addendum to pages 11 and 12. Once you're done, go ahead and do the worksheet on page 82 about factors and prime factoring.